A jar contains 4 red marbles, 9 white marbles, and 2 blue marbles. So a game is played in which if a red marble is drawn, the player gets $6. If a white marble is drawn, the player gets nothing. And if a blue marble is drawn, then the player gets $20. And the price to play the game is $4. So we want to find the expected value for one draw. Okay, now there are 2 ways to find expected value, right? The first way is to find a fair price and then subtract the $4 from that amount. The second way would be to incorporate the $4 into the payouts, okay? So I prefer to find a fair price first, okay? So let's look at what are all the payouts that are possible and the probability of each. Okay. So in this case, there are 3 balls, or 3 different color balls, I guess I should say. Okay. So what happens if you draw the red ball, right? If you draw a red ball, you'll get $6. If you draw a white marble, I guess I should say, if you draw a white marble, you actually don't get anything. And if you draw a blue marble, you win $20. Okay, now the probability of red, now there's 15 balls total, right? And out of those 15, 4 are red. So the probability of getting a red marble is 4 out of 15. The probability of getting a white marble is 9 out of 15. And the probability of getting a blue marble then is 2 out of 15. Right, so we want to multiply the payout times the probability and then add those, in this case, add these 3 results together, right? 6 times 4 gives us 24. Okay, 0 times anything is just 0. 20 times 2 here gives us 40 over 15. So when we add these, 24 plus 40 gives us 64 over 15, which when it's reduced is, I have to round this, right? 4.27 or $4.27, right? Remember this here, this is called the fair price. Okay, we do not incorporate any upfront payment or the price to play the game anywhere in these calculations, right? This is just based on the payouts themselves. Okay. But then the question says, well, the price to play the game is $4. So we know that the expected value is the fair price minus the price to play. Okay? And we notice that in this case, say, wait a minute, we actually get an expected value that is a positive result, right? It's positive 27 cents. That is the expected value here. Okay. So what does that tell us? It tells us that over the long run, every time we play this game, the player would expect to win now, positive, right? The player would expect to win 27 cents every single time. So if they played this 10 times, right? If you play 10 times, you would expect to win about $2.70, right? If you played this game like 100 times, right? You would expect to win about $27, okay? Now, of course, because the expected value is positive, that is always in the advantage of the player, right? So most casino games, the expected value is negative for the player, which sort of makes sense, right? And over the long run, yeah, the casino is going to make money based on the expected value. Now, once again, stranger things have happened, right? Is it possible that you can get like, you know, 3, 4, 5 blue marbles in a row? Oh, sure, it's possible, right? But then the longer you play this game, the more things are going to even out. Okay, so remember, the expected value does not mean, okay, what's going to happen in a short amount of time, okay, because we know that anything can happen. But over the long run, as you continually play this game, right, that is what the expected value represents.